Today's lesson, section 8.3c, we'll be talking about De Moivre's theorem. Now, for De Moivre's theorem, we are given if z is equal to r times cosine theta plus I sine theta, and then any integer n is given to us, then we can take z to the nth power, where that will equal r to the nth power times cosine of n times theta plus I sine of n times theta as well. So the n is just giving us a value where we take it to the power for our modulus, and then we take that number n times our theta. So it's kind of like taking your multiplication of two different, or of this polar form complex number times itself, and doing it n times. You're just compacting it into a simpler form. So if I want to find 1/2 plus 1/2 I to the 12th power, this means that my n would equal 12. And so now I first need to find what this complex number is in polar form. So I need to find my r. So that gives me 1/4 plus 1/4. Gives me 2/4. And so here, let's reduce, so that gets you 1/2. So the square root of 1 is 1, square root of 2 is just square root of 2. So then that would be my r value. And then I would like to find my argument or my angle. So then I take my b divided by my a, which would give me 1. So the inverse of tangent of 1 would be pi over 4. So this for argument, remember it's graphed be 1/2, 1/2. So it should be in the first quadrant. So that's why I don't have to change that value to anything. Okay, so now I've got my angle and my r, and now I can plug it into De Moivre's theorem. So then our n is 12. So now r, or 1 over square root of 2 to the 12th power, will be taken times cosine of 12 times pi over 4 plus I sine of 12 times pi over 4 as well. So then 1 over square root of 2 to the 12th power would just give us 1 for the numerator, and square root of 2 over 12, let's think about this over here. So square root of 2 is the same thing as 2 to the 1/2. So if I take that to the 12th power, you're multiplying, it's power to power property, so I multiply. So 2 to the 1/2 times 2 to the half, or times 12 would give me 2 to the 6th, and then that would be the same as 64. So that would be my fraction that I have in front. And now cosine, we can reduce the 12 times the pi over 4 by allowing 12 to go into 4 3 times, so that gives me 3 pi. Now here, we would like to be able to find the normal complex number, rectangular form of it, and so now I want to simplify these. So cosine of 3 pi is the same thing as pi, so that gives me -1, and then plus I times sine of 3 pi would be 0. And so then 0 and I cancel each other out, so you're left with -1. So then multiplying 1/64 times -1 gets you -1/64. And that would be your answer. Okay? And so that's all you're really looking for in De Moivre's theorem, to be able to exponentiate a complex number that's in polar form. Okay? Have fun.